Hello friends, in this session we shall be discussing the mathematical and the English angle in inequalities, which we call it as reasoning in inequalities. So let's start. Now kindly refer to the table. In the table you would see that there are 10 points that we have taken. The first 5 points are the affirmative cases. Now the definition of affirmative cases here means positive cases, and the remaining 5 points, the enumerations starting from 6 and ending on 10 are the negative cases. And then we shall explain this thing to you with the help of examples. For example, the first 5 cases, let us start off the discussion for this with the help of examples. Now when we say examples, we'll be taking examples for all these 10 cases, but initially we would start off with the first 5 cases, which are the positive cases. Okay, so now the first case, you would see the first 3 cases are the basic cases that we talk about in inequalities. For example, we would say the age of a person is greater than 10 years. Let's say the age of a person is lesser than 10 years. The age of a person is equal to 10 years, etc. But then these are the basic ones. And then the next thing that we can do here is, if I talk about the 4th case and the 5th case. So the 4th case is a combination of the 1st and the 3rd case, and the 5th case is a combination of the 2nd and the 3rd case. And the remaining 5 cases that we are talking about, which come under the head of negative cases, would be all those cases where we are negating the first 5 cases, which is why we call them as negative. Okay, so let me start. So by the end of this session, after we would have taken ample examples, we would establish a link between the affirmative cases and the negative cases, so that ultimately we are able to take our learnings to the next level, thereafter to the next level. Okay. So, taking an example here, now if I say that x is a real number which is greater than 2, x is a real number which is greater than 2, right? So, what am I trying to take here? Now, I'll write this number once again. So, we are taking an example of x is greater than 2, and we are saying that x is a real number. So now when we are saying x is greater than 2, what do we mean to say? So if I say a number like 2.1, 2.2, 2.3, 3, 4, 5, 6, 100, etc. These are all numbers which are greater than 2, and they are real numbers. Right? But we are not saying that the number is equal to 2. Now in this case, if I say x is equal to 2, now let me take the second case here, x is less than 2. Now when I take x is less than 2, that means I am talking about all real numbers, because x is a real number here, which is not equal to a 2, which is not greater than a 2, but at the same time it is less than 2. So which numbers are we talking about? We are talking about numbers like minus 100, let's say minus 2, 0, 1, 1.8, 1.9, etc. such that the limiting value here is 2. Right? Okay. At the same time, we could have taken the third case, which is x is equal to a 2, which means strictly equal to a 2, x cannot be lesser than 2, and at the same time x cannot be greater. Please mark the words being used and the representations being used. We said when we are talking about 2, we would not talk about the 3. I will not talk about the remaining 2. The remaining 2 here are, we will not talk about x less than 2. At the same time, we will not talk about x being greater than 2. Let's come back to the first case. So first case was x is greater than 2, where x is a real number. So what do we mean to say? We mean to say that x is not equal to a 2, and at the same time we are not talking about x being lesser than 2. The same analogy can be established for the second case. So we are talking about, strictly we are talking about all real numbers lesser than 2. In that case, we are not talking about 2, and at the same time we are not talking about a real number being greater than 2. So this is another way to interpret and convert this affirmative case into a negative case. I hope by now you would have understood that what are we trying to do? We are trying to establish a synergy between the affirmative case and the negative case. Okay, so can we say that the first case that we talked about, greater than, x is greater than 2, so at the same time we can say x is neither equal to a 2 nor lesser than a 2. So can we say that this is just like saying the same? So we have established a synergy between them, right? Now let us talk about the second case wherein we talked about x is lesser than 2. So either I talk affirmatively or I talk negatively. So if I'm talking negatively and I'm saying and I'm using a negative connotation for the affirmative one, at the same time I can use an affirmative connotation for a negative one. For example, if I'm saying x is neither greater than 2 nor equal to a 2, this is a negative way of presenting something. At the same time, I can present the same case in an affirmative manner, which is just like saying if x is neither greater than 2 nor equal to a 2, in that case, what am I trying to say? What am I trying to convey? I'm trying to convey that x is less than a 2. So can we establish a synergy between the second case and the seventh case? Yes. So the synergy has been established. Let's talk about the third case, and reasoning now says, now putting an element of reasoning, and by now you would have understood that at Shiksharthi we basically give you the inputs first, the learning inputs, so that you can reason it, take it to a next level, and then finally you reason it further and then take it to the level of refinement, and you keep on doing this thing throughout. That is how a learner grows in terms of knowledge, or the knowledge grows inside the learner. Now talking about the third case, and let me first present it in an affirmative manner. If I am saying that there is a person whose age is 2 years, and here now I am taking the value of x as 2 years. At the same time, I can present this affirmative statement in a negative way also. What is the way of presenting this affirmative statement in a negative way? This person's age is neither greater than 2 nor lesser than 2 years. This is another way of presenting the same. So a synergy between the third case and the eighth case is also established. At the same time, we are left with 4 cases. Now when we are left with 4 cases, let us see what are we talking about here. So the fourth case we discussed earlier is a combination of the first case and the third case. So let us say that I am saying that x is greater than 2 or x is equal to 2. Please understand that the word or here symbolizes that both the values are disjoint to each other. For example, you cannot say x is, there is a person who is 2 years of age and at the same time the person is greater than 2 years of age. This data becomes inconsistent, which is why the word or here symbolizes disjunction. Okay, once you have understood this, And let me take the earlier example that I was taking, that x is a real number which is either equal to 2 or greater than 2. What is the negative way of presenting the same? That means x is not less than 2. The last case here, which is the fifth case, is when we are saying that x is less than or equal to 2. The point to understand here is x is either equal to 2 or less than 2. You cannot use both the things together. Otherwise, they contradict each other. So you need to understand here the word or here plays the role of a disjunction. These are disjoint sets. So when we are saying x is less than 2 or greater than 2, the negative of this is x should not be greater than 2. And let me put this inside a box so that you are able to, or we are able to establish a synergy between what? Now, point number 4 is the same as point number 9. And point number 5 is the same as point number 10. I hope you have understood this. Now finally taking it to a level wherein if we talk about how to represent greater than, lesser than or equal to. So now if I say I have to represent x greater than 2 on the number line. So let me just draw a number line here. Let me say this point is 0, 0. Let's say this is 1. Let's say this is 2. And the dots symbolize that we are talking about the points which are inclusive of. Why inclusive of? Because equal to means inclusive and not equal to means exclusive. So when we are saying greater than or we are saying lesser than, that means we are basically referring to not equal to. So if you are making notes as I am writing, you can make a note of this. I repeat, the first 2 points are the negation of the third point. So in a certain sense, what is an inequality? An inequality is basically not an equality in the very first place. So when you don't talk about inequality or when equality does not exist, it is then only we talk about inequalities. But when we are talking about inequalities, then the basic word that is supposed to be referred to is equality only, which is why the third enumeration talks about equal to. So the basic concept of greater than or lesser than is what is the basic concept is not equal to, represents, or not equal to is represented by either greater than or lesser than. Now, if somebody says x is equal to 2, how will I represent this? I will just draw a line and I would use a dot. Here we are using an extended dot just to show that the dot means that the point is included. So if I'm using a dot, that means this point is included. And if I'm using an arrow and the arrow touches that point, so the point where the arrow touches that point is excluded. This is basically the concept of equal to and not equal to. So if I am supposed to represent x is greater than 2, I'll start off from x is equal to 2, draw a line, mark the words being used, draw a line. Now line is represented by 2 arrows at the extreme points, which means that the points are excluded. So here when I say x is greater than 2, that means 2 is not included. And at the same time, if I am saying x is less than 2, I never said x is equal to 2. We are saying that x is less than 2. So this arrow comes from the negative side. Let's say this is the negative side, which is minus infinity. And this goes on to the positive side, which is plus infinity. Please recall, at the very beginning, I said that reasoning in inequalities is basically a combination or a perspective of a combination of English and mathematics. Okay, now if I have to represent x is greater than or equal to, and let me use a green colored arrow here. So if I have to represent x is greater than or equal to, what will I use? I'll use a ray. Keeping in mind that this point was 2. And last but not the least, if I am supposed to represent x is less than or equal to, so in that case, again an arrow in the opposite direction. So just let me put the things in perspective here. I used the black colored arrow. Let me use the perspective here. So I used the black colored arrow. Let's say this is 2 and this is minus infinity. So what am I representing here? I am representing x is less than or equal to 2. Coming down to the green colored arrow, let's say this is 2. Dot means that the point is inclusive. Infinity by default cannot be measured. So here what am I representing? I am representing x is greater than or equal to 2. Let me come down to the red colored arrow, wherein, so if I talk about the first two cases, let me write down the first two cases also here. So this was a ray, and the second representation was also of a ray, though it is a green ray, unintended, it's not a blue ray. Okay, so now coming down to the third case, wherein we are talking about arrow to arrow. That means this representation is known as a line. All of us, we know this. And in this case, let us say this starts from minus infinity and ends on 2. So what are we representing? We are representing x is less than 2 and greater than minus infinity, which can be neglected here, because when we say x is less than 2, that means it is indicative of that x. Another way of writing the same is x starts from minus infinity and ends on plus 2. Another way of representing the same. The same we could have done here also for black colored ray. The last but not the least, the blue ray that we have used, arrow to arrow. I'm sorry, it's not a ray. That was just pun intended. So the blue line that we have used here, so starts from a 2 and ends on plus infinity. How would we represent this? It is represented by x is greater than 2. I hope a further introspection on this will help you to understand this to a great deal, so that you are able to take this discussion to the level of refinement, wherein all these things can be used in mathematics, reasoning and English, and in daily life you can use, in real life scenario you can use all these things, which helps you to learn and implement these things immensely.